in this question it says, to protect blood samples from contamination, screening of all donors of hepatitis C is required. The screening test has a sensitivity is going to be 95% and a specificity of 90%. Is used on a sample of donors in which 10% are known to have hepatitis C. So this is from a population of hepatitis C, of a population where 10% has hepatitis C. Okay? Now, which of the following is the best estimate of the chance that a donor who tests negative is actually free of infection? So this is the most important sentence of the question. It says, which of the following is the best estimate of the chance that a donor who tests negative is actually free of infection? So they're asking us to find out negative predictive value. Now, to find negative predictive value, we have to fill up the box. So let's draw our box right here. Okay, so we're going to start from scratch. So imagine that this is our box. Okay, if I were you, I would draw this out before exam starts because I always tend to rush and make mistakes. So this is positive, this is negative, test positive, test negative. Okay, this is going to be A, B, C, and D. And negative predictive value is going to be D, D plus C plus D. C plus D. That's a negative predictive value, right? Okay, so we know that the sensitivity was 95%. So sensitivity of the disease is 95%. That means that if we consider that of that population of hepatitis C, 100 people had the disease, then this would be 100. I'm going to make this in a different color. So this would be 100, right? But the test picked up 95 people from that 100. So disease positive and test positive was 95, and the rest disease positive was test negative. So this is going to be 5 here. Now this was only for the population who had the disease. What about the rest of the population? We don't have the disease. So we have to take an arbitrary number. So let's say we've taken nice big round numbers like 1,000. Let's say from that 1,000, 100 people had the disease. So that means how many people didn't have the disease? 900 people didn't have the disease. That means disease negative, this entire box would be 900, right? After we find that value, now we know that the specificity of the disease is going to be 90%. So that means true negative is going to be 900 times 90 by 100, right? So we are left with 810, right? So D is going to be 810. So that's the true negative value. Now what about this one? What about D, who are disease negative but test positive? Who are actually don't have the disease but they're testing positive. Those people would be 900 minus 810. That's going to be 90. So here we're going to have 90. So now we have finished, filling out all the blanks. Now we can find our negative predictive value, which is equal to D 810 divided by C plus D. 810 plus 5 is going to be 810 plus 815. Now I have to use a calculator. Okay, so this value is going to be 99%. Okay. So moving back to our question, which of the following is the best estimate of the chance that a donor who tests negative is actually free of infection? The chance of is 99%. So the answer is going to be F.